Right, thank you. Good morning once again. I think we're officially ready to go. So as I mentioned, my name is Nima Salimi. I'm a curator with the IEDB, and I'm happy to begin this morning by just providing you with a very brief overview of the database. This is more or less intended to just give you a feel for how the database is structured and laid out, and many of the themes that I discuss this morning will be recurring. And that's really intentional. We hope that this is a good repetition, but of course, as we move through, we will move deeper, providing more details, ultimately ending with, as was mentioned, the one-on-one opportunities that we could use to delve deeper into your specific work, specific questions. So, as was mentioned, the analysis resource goes back, close to 15 years now. Originally awarded in 2003, but the analysis resource really is composed of two facets. There's the database itself, which is the focus for the first part of today, and then there's an analysis resource, or the tools, which is completely different element, interrelated but different. So in terms of the database, this is a repository of experimentally derived epitopes and the contextual assay-based information. And this is primarily from the published literature. So you can see, based on NIAID, our funding agency, our areas of focus are currently outlined as these categories. So essentially all the data that you will see, or most of the data that you'll see, comes from these categories, but is across species. So we capture the data, whether the epitopes are defined in humans, mouse, etc. And you can see, as was mentioned, we've been plugging away for a good amount of years, and that's reflected in the volume of data that's available in the database to date. And of course, it's free and completely web accessible. So one of the challenges that we look forward to, me in particular as a member of the curation team, is how to actually extract these data, because ultimately that's what it is. It's a manual extraction of the data by PhD level scientists who read each manuscript critically and then objectively extract these data and input them into the database. So of course we strive for objectivity, but even more so consistency, because of course, no two papers are identical. You can't really make a formula so much out of it. But you can establish a set of criteria, rigorous set of criteria that can be followed consistently, not only between each paper by each curator, but between curators, so that at the end, as the user, you can be confident that the data are entered objectively and consistently. But furthermore, as you can see here, when we define a set of data that are ontologically based, and you'll be hearing more about that throughout the day, these data can be entered in a format that's context dependent. So, for example, two of you in here may have differing views on what it takes to define an epitope, or what a definition of an epitope is. We try to remain objective and merely reflect what the structure of the epitope was, with the fields in terms of what the sequence might be, the source, and then provide the information in terms of contextual basis for how that epitope was defined in the particular study. So those contextual details would include, for example, how the host was immunized, what was the actual readout in terms of the assay. And this really empowers you as the user to define what you would like to tease out of the database with your query. Literally, you could define on the field level database fields that you're interested in seeing, and therefore you're making the definition of what is returned. So this is, I think, the real power, one of the real powers of our database. This was certainly one of the novelties of it when its inception, in that there was a lot of data there that was basically sequence and source, but it didn't go a whole lot further. But this rich context provides a lot of avenues for analysis as well that you'll be seeing throughout the day. So a little bit more about the literature curation process, as defined here by this sort of flow chart. It is, as I mentioned, very manually intensive, but there is a little bit of automation that's involved, specifically at the front end. So the first question is, where do you get all of these papers that are entered in the database, and how are they chosen? So this is done by a very broad query of PubMed database, which is, I don't know where it stands today, over 20 million references. And we extract on a bi-weekly basis papers that are relevant to the areas that I mentioned before. And so another automated step would be sort of a homemade classifier that we use to classify these based on their most likely category: autoimmune, infectious disease related, etc. You can see along the line we sort of cut down the numbers. And then the process really becomes one of a manual one. A very expert internal person reviews these abstracts one at a time. His name's Alex, and he basically goes through these papers, confirms the classifier's classification, confirms based on abstract the so-called curatability, but it is not until the final step that these are assigned to the curation team, where the paper is read essentially thoroughly and the data are extracted. So that's the manual curation process, and process really doesn't end there, in that we have, just as you would see with a manuscript publication process, a peer review process internally, whereby when one curator has fully extracted data from a paper and entered it, that will then be passed on to a second biocurator, second set of eyes, to review the work. And this is an iterative process to make sure there's consensus on how the data are extracted and how it's reflected. And only after that consensus is reached is the data made public on the external site for you, the user, to access and query. So historically, as we've already sort of touched on, there's been explosive growth of the data in terms of the number of references or the number of manuscripts that we've curated over the years. We began in earnest in 2003, 2004, and I believe it was 2005 when the database actually became public. And so you can see it's very steady growth. Around 2011, that time frame is where we shifted, in a sense, from being caught up curating historically all the data that was in PubMed up to date, which was, a monumental task. And then moving forward, it basically became maintenance mode. So as data are published, we capture them, curate them, and include them. So in those categories that we focus on, essentially we're in equilibrium right now with PubMed. As they're published, we curate them. And we have roughly a 4 to 8 week turnaround time between publication and it being publicly visible in the database. And in the pie chart here, you can see essentially the current distribution of curated references in the IDB. So, it's obviously biggest slice of the pie is infectious disease related, but this is of course just reflective of, the epitope related literature. Again, we strive to be very unbiased and curate things. And in fact, we often will be alerted of papers that may have sort of slipped through the crack. We encourage that. We go back and reevaluate them as necessary. So this is the homepage that you're going to see quite often throughout the day. My point here is just to stress in the lower left-hand corner, since we were just briefly discussing metrics, on an ongoing basis, these metrics are updated so that you can see sort of as a snapshot how much data is in the IDB at any given time. Prominently in the center of the homepage is our homepage search interface. So this search interface is composed of 6 search tiles, if you like, and you can see each one's labeled. So these are broad classes or categories of data that you can query, whether it be by, for example, the epitope or the source of the epitope, the host, etc. And so we'll be exploring that a lot more throughout the morning and the rest of the day. But this search interface is not exhaustive in terms of the number of fields. It doesn't represent every field in the database, but it's been designed with a great deal of thought and intention and analytics to really capture the vast majority of the queries that our users run. So in that sense, I think it's an excellent launch point for all of us to basically run any query you'd like. And as I mentioned, we'll be showing you example queries throughout the day. So here's a quick example with the focus not being so much on how the data are input into the research interface, but really just to give you an example of what's returned after you do run a query. So if, for example, you were running a hepatitis C virus T-cell epitope query defined in humans, you could use these search fields to define your organism, your host, and delimit your search to T-cell assays that are positive only. And by clicking search, what you'll retrieve is essentially the page that you'll always retrieve after running a query, which is a tabular, organized form of data results or hits. And so what you see essentially at the top is filters that show you the query you just ran. So each parameter up here is defined by you, and those are displayed as confirmation of the query that you're looking at. Just below that, the results are laid out in tabs. So the first tab by default will be the epitopes tab, and you can see each, I'll walk you through the others, but they're basically categorized in terms of query results for that particular query, and each one has a number in parentheses indicating the number of records corresponding to that particular tab. So in the epitopes tab, you can see here each epitope and its source is a single row. And in the far right-hand column, you have some simple metrics in terms of how often it occurs in references and the number of assays that particular epitope is represented. And there are throughout all of these tabs links that you'll see, various links that we'll be touching on. For example, a details link on the epitope will do just that. It'll provide you more information about that particular record. So by following it, you'll, for example, get a narrative summary about that particular epitope, and then more or less an inventory of how often that epitope is studied in various different assay categories, be it a ligand, MHC ligand assay, B cell, T cell, and then by specific assay types. And these are also links that you can sort of click to have a quick access point if that is of interest to you. But I'll keep it there because I know Randy will be discussing this a little bit more briefly. But as I mentioned, these types of details are available throughout other parts of the database as well. So we encourage you to kind of dive deeper and explore those deep levels. But back to the tabs. So the second tab is called the antigens tab. So this is essentially the, in this example, the protein sources in which those epitopes that were retrieved are found. And so you can see, for example, genome polyprotein, F protein, et cetera, again, provided metrics here. You can see, no surprise with HCV for polyprotein, there are quite a few epitopes, over 1,600. And so these epitopes are obviously come from a broad array of strains, broad array of proteins and all these manuscripts, different isoforms of those proteins. So in order to represent these data in a visual form that can be somewhat more easily relatable, we created a tool called the Immunome Browser that can be launched by clicking this graphical icon that you see from the antigens page. And what the Immunome Browser does is it essentially takes those epitopes that were returned in the query and maps them on a reference antigen. So if you want a canonical antigen of the particular protein that you chose. And so you generate two graphs, and on the x-axis you can see you have the position in the reference protein. And this creates a visual heat map, if you will, In the top graph, what we're looking at is response frequencies, so number of subjects tested versus responded at each position. And then in the bottom, you're looking at assay counts. And so what this provides is, as I mentioned, a kind of a snapshot, a global view of how these data visually lay out on an antigen. And then it also allows you to distinguish by comparing the two graphs, are there areas that are low negative response frequencies because they simply weren't studied, or is it because they were studied and, for example, low reactivity or no reactivity? And in the end terminus of this example, you see very low frequencies on this side, but if you switch down here, you can see that those were, in fact, pretty well studied, a lot of negative responses. And so this tool is available, as I mentioned, from the Antigens tab on demand. You just click it, but it's also a standalone version that is on our analysis resource where you can create these graphs by providing your own sequences, your own data, basically. Okay, so moving on to the Assays tab, the center tab there. Essentially, in each of these rows, what you have is a single data point or a single contextual description of that epitope. So what was the epitope? How was it described? How was it defined? And the columns are individual data fields, but again, those are just a condensed version in the table form. So you can see, for example, this particular epitope was studied in humans who had HCV and were reactive against the antigen, in this case, the epitope, and the restriction is shown. But again, there are more details than this that can be explored by clicking on the ID for each individual assay. The receptors tab, several years ago, we embarked upon effort to capture T cell and B cell receptor data where available, when it's epitope specific and included in the manuscript. So with the recent explosion in technology and the ability, we see this more and more in the papers that we encounter, and we include those again in the results summary. What you're seeing is the CDR3 regions in this particular example for the TCR. You can see that one could switch to the BCR if you ran a B cell query and see those as well. But again, where available, for example, nucleotide sequences, complete protein sequences of the CDRs, and even gene usage is available, and those can be accessed by clicking the details and delving deeper into that data. Finally, the References tab is simply a list of the papers from which, or in some cases direct submissions, from which those data are extracted. So if you want a quick summary of the publication details, links to PubMed, you can get it on the References tab. Note that as we sort of pull back here from the tabs, what becomes visible on the left-hand column, which is always present, is those those query tiles. So similar to what we saw on the homepage, these tiles are laid out this time more in a kind of vertical pattern. But the query parameters that we defined in the original homepage query are pre-populated. So what this results page query allows you to do is to refine your query if you'd like. And in fact, there are two additional tiles, one being the receptor that is not on the homepage, and another one below that's not shown here, which is called the References tab, that you can define more specific parameters about references you're interested in. And so in real time, you could look at your query results, refine them, and then run another query, and that will be reflected in your filters. Additionally, another feature that's available throughout each of the tabs that I overviewed is an export results link. And so by clicking on that, you can export the results in that particular tab to a CSV file, a spreadsheet that you could locally download, save, analyze, share, all of those types of things. So this isn't available with the query, but of course you could also download the entire database and work on it offline. You'll hear more about that as well. With regard to help, so of course, it's hard to beat face-to-face interaction, but we do strive to provide help throughout the database. So this comes in two forms. One form is these question marks that occur at various fields, and by simply mousing or clicking on them, you'll get a brief description of what that field is capturing. You will often see a Learn More link in that bubble, and you can click that, and that'll go to our help page, and it'll give you much more detail. If you would like to contact us directly, there is an official help menu item, and you can fill out a help request, and this will come directly to us. And in fact, I will get it, and I will do my best to respond to you. Usually you'll get a response within hours. If I'm not the right one to answer it, I'll make sure the right person does get it. But we encourage you to contact us. We look forward to that. And again, as was mentioned earlier, our user interactions really help us fine-tune the database. So we're here for you whenever you need to submit a request. You could also just email us directly without using the help form at this email address from your own email account. Okay, and I will close this segment by just reiterating what was mentioned by both Joe and Alex this morning, that we really do see this as, I think, our most important outreach opportunity as, custodians of the IEDB. The IEDB is continually evolving, and there's a very important feedback loop that happens between our users and us, and many of the features and layout ideas that you see today are as a result of previous user workshops. So we look forward to getting your feedback. We don't want this to be one-sided. Obviously, your utility, your optimal utility of the database is primary goal as well, but we encourage you to be frank with us and give us feedback so that we can take that on back to our team and implement it if possible.